Welcome to channel Guruvartha Kirti. Myself N.A. Papati, Assistant Professor EC, Vaigai College of Engineering. In this video, we are going to discuss about the proof of sampling theorem. So before going to discuss about the proof of sampling theorem, we have to discuss little bit about the introduction about pulse modulation. So modulation is nothing but, as we know already, modulation is nothing but it is the process of changing the characteristics of carrier signal with respect to the message. Based upon in analog communication, we'll be having three different kinds of modulation: amplitude modulation, frequency modulation, and phase modulation. In case of analog modulation we'll be having, there are two important things. One is information, another one is carrier. Here both are analog. Information as well as carrier both are analog. Information is low frequency signal, carrier is high frequency signal. So in case of analog communication system, both are continuous time signal, because in analog this can be represented as a continuous time signal, right? Information as well as carrier signal both are represented by means of continuous time signal, right? So information is also represented as a sine wave signal. Carrier is also represented as a sine wave signal, but there is a little bit difference between information and carrier. Information will be low frequency signal. It varies between 20 to 20 kilohertz, but carrier is varied as a high frequency signal. This can be represented in terms of mega to gigahertz, right? So this is about the modulation. In terms of pulse modulation, in analog modulation both are represented as continuous time signal, but in the case of pulse modulation is also a kind of modulation. It is the process of changing the characteristics of pulse carrier is varied with respect to the message signal. This is about the definition of pulse modulation. Pulse of the carrier definition. I am repeating. The pulse of the carrier is varied with respect to the message signal. You consider here, this is about the message signal. This is about the digital pulse. There will be a digital pulse. This can be represented as like this. In analog communication, information is also continuous time signal. Carrier is also a continuous time signal. That means information is low frequency, carrier is high frequency. Both are continuous in digital communication. In the same way, we are defining the pulse modulation. In pulse modulation is represented as what? Pulse of the carrier. Definition is about pulse of the carrier is varied. Pulse of the carrier is varied with respect to message signal. So here in pulse modulation, information is continuous time signal, but carrier is digital pulse. Carrier is digital. This message. This is about message. This is about carrier. This is continuous time signal, but this is about pulse signal. So pulse of the carrier is varied with respect to the message signal. So what is the need for pulse modulation is that many signal in modern communication systems are digital. We know that already in the introduction class. Also, analog signals are transmitted digitally. We can convert the analog signal into digital means, and reduces distortion and improvements in signal to noise ratio. The performance can be evaluated by means of SNR, signal to noise ratio. In pulse modulation, there are different kinds of modulation technique is there. Pulse amplitude modulation, pulse width modulation, pulse position modulation, pulse code modulation, and delta modulation. All those things will be having the carrier as pulse. Also, all those modulation technique will be having the carrier as pulse. In continuous modulation schemes, some parameter of modulated wave varies continuously with respect to the message. As I said earlier, in continuous wave schemes, some parameter, that means amplitude, frequency and phase of the parameter of modulated wave varies with respect to the message. In analog pulse modulation, some parameter of pulse is modulated by a particular sample value of the message. Here in pulse modulation, the carrier pulses varied with respect to the message signal. So based upon the pulse of the carrier, it can be categorized as pulse modulation is categorized as analog pulse modulation and digital pulse modulation. Analog pulse modulation and digital pulse modulation. Pulse modulation can be categorized as two types: analog pulse modulation and digital pulse modulation. So in analog pulse modulation, there are further classification is there: pulse amplitude modulation, pulse width modulation, pulse position modulation. In digital pulse modulation, pulse code modulation, delta modulation. So based upon the category, analog pulse modulation is categorized as three: pulse amplitude, pulse width, pulse position. In digital pulse modulation, this can be categorized as pulse code modulation and delta modulation. So pulse modulation, here the representation is there. This is about the continuous time signal. This is about the message. This is a low frequency signal. And pulse amplitude modulation is nothing but, you consider here there is a constant pulse width is there. Constant pulse width there. So pulse amplitude modulation means amplitude of the pulses varied with respect to the message signal. Amplitude of pulses varied with respect to the message signal. You consider this is about, I'll tell you in detail. So this is about what? Carrier pulse. This is CFT. This is T. In x-axis, this can be time domain representation, time representation. In y-axis, it can be obtained as a amplitude. So based upon the message, the carrier amplitude will be varying. Carrier amplitude at this instant, there are different instant. So in each and every instant, the carrier amplitude will be changed according to the every instant of message signal. So based upon, we will be getting the output. This is called pulse amplitude modulation. At this instant, in this instant, the amplitude will be low, so amplitude will be low here. Based upon this, and in this instant, there will be amplitude is high. When we compare this side, when compared to this amplitude is high, so this is also high. At this instant, the amplitude is decreasing. This is increasing, this is decreasing, and again increasing. So in decreasing means the amplitude will be decreased. Decreasing means the amplitude will be decreased. Here also the amplitude will be decreased. Here also the amplitude will be decreased. So carrier amplitude of carrier pulse, constant carrier pulses varied with respect to the instantaneous value of message signal. This is called pulse amplitude modulation. In the same way, we are categorizing the width of the pulses varied with respect to the message signal. You consider here the pulse width is there, carrier constant. You consider here the carrier pulse is there. This is a constant carrier pulse. So the width of the pulse, carrier pulses, this is CFT, this is T. So width of the carrier pulses varied with respect to the message signal. So based upon this is increasing amplitude, decreasing amplitude, increasing. Based upon that, amplitude is decreasing, so width will be decreasing. Increasing amplitude, the width will be increasing. Decreasing amplitude, the width will be decreasing. So based upon the width is varying, the carrier width is varying with respect to the message signal. This is called what? Pulse width modulation. Next thing is about pulse position modulation. So pulse position modulation, the position of the carrier pulse is varied. This is about carrier pulse. The position of the carrier pulse is varied with respect to the message signal. And this can be again, I'll tell you in detail. If the carrier position is shifted, if the amplitude is increasing, means the position will be shifted to right. If the amplitude is decreasing, means the position will be shifted to left. So if the amplitude is increasing means the carrier position will be shifted towards right. Shifted towards right. If the amplitude is decreasing means the carrier position will be shifted to left. So in this way we are obtaining the pulse position modulation. Pulse position modulation. So the carrier pulses shifted towards right when the amplitude of the message signal is increasing in amplitude. If the message signal amplitude is in decreasing manner, means the carrier amplitude will be, the carrier position will be shifted towards left. So this is called pulse position modulation. Next thing is about pulse code modulation. Pulse code modulation means your analog signals are sampled at a rate fs is greater than or equal to 2 omega and then converted by means of coded pulses. Converted by means of coded pulses. This is called what? Your pulse code modulation. So the definition of pulse code modulation is that we will be detailed discussion. We'll be having detailed discussion in pulse code modulation generation and deduction. We will be having detailed description, right? So but here you can understand that your analog signals, this is about the carrier na, pulse carrier. This is about the pulse carrier. This is about the pulse carrier. Here the carrier pulses, here the message signal is sampled and then converted by means of coded pulses. Coded pulses, 8 bits, 16 bit, 32 bit. So based upon that, it can be categorized coded pulses. Analog signals are sampled and then converted by means of coded pulses. This is called what? Your pulse code modulation. Pulse code modulation. Delta modulation means 1 bit per sample is encoded. Only 1 bit at a time can be coded. Only 1 bit at a time. In delta modulation, the pulses, the digital signal can be in terms of the step size. In terms of the output will be in terms of step size. Analog signals are 1 bit at a time. The signal can be sampled. This is what your delta modulation. Delta modulation in delta, the delta modulation concept will not be there in your syllabus. But pulse code modulation is there. It is for 16 mark. So up to this, the introduction of pulse code, introduction of pulse modulation is over. We'll be discussing the sampling theorem. So we'll be discussing in detailed way in the generation of pulse code modulation and demodulation. So very basic thing is, if the in digital communication system we'll be giving the information as analog, means we have to convert it into digital. There are very 3 basic building blocks will be there for the conversion of analog signal into digital, that you consider here. When we convert analog signal into digital, A to D conversion block consists of 3 things. Majorly 3 things: sampling, quantizing, encoding. Sampling, quantizing, encoding. So there are 3 basic things happened in the process of converting analog into digital, right? So this is about the analog to digital conversion block. A to D conversion block consists of 3 major things. One is sampler, quantizer, encoder. This is about the very, very, very important process in A to D conversion, right? So naturally we will be giving analog signal as an input to the digital communication that can be converted into digital. So when we convert analog signal into digital, the three processes are involved. One is sampler, quantizer, encoder. Sampling means your analog signals are sampled at a rate. This is about the PAM signal. Analog signals are converted. This is about continuous time signal. This can be sampled at every interval by means of sampling theorem. Fs is greater than or equal to 2 omega. That we will be studying in sampling theorem. So at every instant the signal is sampled. So this is what PAM signal, pulse amplitude modulation. For that purpose, we will be having in sampling, we will be giving carrier pulse. We will be giving carrier pulse. Based upon the carrier pulse, the signals are sampled at every instant. So at every instant, there will be a peak. There will be a peak. This is called PAM signal. So after sampling, this can be given into quantizing. Here there are two kind of process will be happened. One is truncation. Another one is rounding. So after quantization, truncation and rounding. So truncation means what does it mean? What does it mean? If you are having this kind of information after converting, truncation means this will happen just like this. Truncation means this can be, suppose you consider this as amplitude 2.1. 2.1 means by means of truncation this can be truncated to 2 volt. Amplitude is 2 volt. Rounding means next higher integer we will be considering. This is about 2.5 means 3 you will be considering. So truncation means so if you are getting this kind of information this can be flattened by means of truncation and rounding. The pulses can be flattened by means of truncation and rounding. Truncation means will be cutting. Rounding means next higher integer will be taking. The amplitude will be taking us next higher integer. So this is what quantization. Encoding means by means of ones and zeros we will be calculating. Suppose if we will be getting this kind of output as truncation means this waveform is considered as 1, this waveform is considered as 0, this waveform is considered as 1, this waveform. The positive pulse is considered as 1, negative pulse is considered as 0. So 1 and 0 we will be making by means of encoding. This is another kind of representation of digital signal. So this is what the very basic conversion of A to D. A to D conversion means there are three important blocks will be happening. One is sampling, quantizing, encoding. So this is about the elements of PCM system that we will be discussed in later. This is a topic, 13 mark topic. So we will be discussed in detail in that particular topic. Okay. So up to this, the conversion, pulse code modulation introduction is over. This is what your pulse code modulation introduction. So up to this, I wind up the session. Thank you. Thank you students for watching.